Today, we're jumping into Apache Spark and taking a look at how its core building block, the RDD, lets you build some seriously powerful data pipelines. Okay, so let's just dive right in. You're a pro at writing a killer SQL query, right? You can pull anything you need from a database. But what happens when that database isn't a neat, tidy server, but terabytes of data just scattered across a huge cluster of machines? You can't just throw a select star at that and hope for the best. You need a totally new way to think about your data and a new set of tools to go with it. So the very first mental shift you gotta make is moving from the idea of a table to something Spark calls an RDD. In the world of Spark, the RDD is everything. It's the fundamental piece you'll be working with to tell Spark what to do with all that distributed data. So what is an RDD really? Well, the name kinda gives it away. It's a resilient distributed data set. Think of it like a collection of items, kind of like a table is a collection of rows. But this collection is sliced up and spread across many different machines in a cluster. The really important part here is that each piece, or partition, can be worked on in parallel. Okay, RDDs have these three core properties you just have to get. First, they're immutable. That means you can't change them. Once an RDD is created, it's set in stone. Instead, you create new RDDs from existing ones. Second, they're distributed, which we just covered. And third, and this one is a real game changer, they are lazily evaluated. This means Spark doesn't actually do anything until you ask for a final result. When you run a SQL query, you hit enter, and the database starts grinding away immediately. Spark, it's different. You first build up a recipe of all the things you want to do, and it only starts cooking when you finally say, okay, give me the result. It's incredibly efficient. All right, so how do we actually start building this recipe? We use these things called transformations. And look, if you're coming from a SQL background, the basic ones are going to feel super familiar. Let's look at the Spark versions of your bread and butter where and select clauses. In SQL, you use a where clause to filter out rows you don't want, right? Well, in Spark, you use the filter transformation. You just give it a little function that says true for the things you want to keep. The goal is exactly the same, get just the data you need, but the method is a little more programmatic. And what about select? In SQL, you use it to pick columns or maybe apply a function to them. Spark's version, map, MEP, is kind of like that, but on steroids. It takes every single element in your RDD, every row, and lets you apply a function to transform it into something totally new. You can just grab a field, like with select, or you can completely reshape the data. It's your go-to for any one-to-one change. Now, those one-to-one transformations are great, but what if one row in your data needs to become, say, 5 rows in your output? For that, we're going to need a different tool from the toolbox. Let's put a real problem on the table. Imagine your RDD is just a list of sentences, like the 2 strings you see here. Your job is to create a new RDD that contains every single word, all on its own. It's a classic one-to-many problem. That first line needs to become 2 new elements, and so does the second. So how do we pull that off? So if you tried to be clever and use map to split the sentences, you'd end up with what you see on the left, a list that contains 2 other lists. It's nested. Not what we want, right? But check out the result on the right. A single, clean, flat list of all the words. That is the magic of flat mapping. It's like doing a map and then immediately flattening the result. It's the perfect tool for these one-to-many jobs. Okay, we've got a handle on transforming one data set, but a huge part of data work is combining multiple data sets, right? In SQL, you've got your union, your intersect, all that good stuff. Well, guess what? Spark has direct equivalents for all of those. And here it is. This is basically your translation guide from SQL to Spark. Union sticks 2 RDDs together, just like union all. Intersection finds only the elements that are in both. Subtract removes elements. The concepts you already know inside and out from SQL, they apply directly here. All right, now for the really cool part, the resilient in RDD. We've been talking about building this recipe of transformations. But what happens if one of your 100 machines just dies right in the middle of a huge job? Does the whole thing just crash and burn? The answer is a big no, and this is why. As you're telling Spark what to do, it's not just doing it and forgetting. It's building a map, a blueprint of every single step. We call this a lineage graph. You can see a simple one here. We start with a file, we filter it 2 different ways, and then we union the results. Spark remembers this entire chain of events. And that lineage, that recipe, is the absolute key to resilience. If a machine holding a piece of your data goes down, Spark doesn't panic. It just looks at its blueprint and goes, oh, I know how to remake that piece of data. It just replays the recipe for that specific lost part. Your entire pipeline becomes fault-tolerant automatically. So let's put it all together. We've got these building blocks, transformations to shape data, and this lineage graph to make it all resilient. What's the big idea here? If there is one thing, just one thing you take away from all this, let it be this right here. An RDD isn't really a bucket of data like a database table is. It's the instructions on how to get the data. It's a recipe. Shifting your thinking from data as a static thing to data as a set of instructions is the key to unlocking Spark. And that really leaves us with a final thought. If your entire data pipeline is just a recipe, you're not just a data analyst running queries anymore. You're basically an inventor. You're not stuck with the limits of SQL. You have an entire programming language at your disposal. So the real question is, what new recipes are you going to invent? And that's it for this explainer. Hey, if this helped you connect the dots, do me a favor and hit that like, share, and subscribe button. We'll be back with more. Thanks for tuning in.